The following grouped frequency distribution summarizes the number of minutes to the nearest minute that a random sample of 200 motorists were delayed by road work on a stretch of motorway. So this is the delay time, and this is the number of motorists. In other words, this is the class and this is the frequency. We have to draw a histogram. To draw a histogram, we need to have the class boundaries in the x-axis and the frequency density in the y-axis. Let's find the frequency density first. Question number A. Frequency density equals to, you have to notice that there is a gap here. 6, then we have a gap 7, 8, then we have a gap 9, 10, then we have a gap 11. So since there is a gap here, but the data is supposed to be continuous data, so we have to do some continuity correction to fill up the gap. This is done by just putting a 0.5 to fill up the gap. In order to find the frequency density, the formula is frequency divided by class width. Class width is going to be upper boundary, class boundary, which is 6.5, minus the lower boundary, which is 3.5. So instead of doing 6.5 minus 3.5, 8.5 minus 6.5, we can do one thing. We can use a trick. 6 minus 4 plus 1, so this would be 6 minus 4 is 2 plus 1 3. So frequency density is going to be 15 divided by 3. The next one is going to be 28 divided by upper boundary is going to be 8.5, lower boundary because of the gap, so it's going to be 6.5. so instead we can do 8 minus 7 is 1, 1 plus 1 2, so this would be 2. Then the next one is 49 divided by 9 is going to be, upper boundary is 9.5, lower boundary is 8.5. It is going to be 9.5 minus 8.5 1, or you can do 9 is the upper boundary and the lower boundary is also 9, so 9 minus 9 is 0 plus 1, so this is going to be 1. When you have a single term, it is just 1. Then 53 is divided by, class width is going to be 10 minus 10 is 0 plus 1 is 1. Then we have 30 divided by 12 minus 11 is 1 plus 1 2. Then we have 15. 15 minus 13 is 2 plus 1 3. And then we have 10. 20 minus 16 is 4 plus 1 5. So this is going to be 15 by 3 is 5. 28 by 2 is 14. 41 by 1 is 49. 51 by 3 is 53. 51 by 1 is 53. This is 15. This is going to be 15 5s 15, 3 5s are 15, and this is going to be 2. This is the class boundaries. This is the height of the histogram. The frequency density is the height of the histogram. So the class boundaries, now we have to put it here on the x-axis. Let's directly draw the histogram now. So let's draw the x-axis here. Okay, so this is the x-axis and the y-axis is going to be here. I hope this is straight. Okay. Okay. So this is the y-axis. We have to label the histogram since the data here is delay time. So we have to write here delay. Let me use something darker. Delay. So delay time in minute. This is the x-axis. The x-axis will also be the data. So the data is delay time, and the y-axis is always frequency density, FD. This is the y-axis. This is the origin. Let's label it. So it starts from 3.5 because we have to do the continuity correction because of the gap here, and ends at 20.5. So if we take 5 like this, so 5, 10, we can take actually more. We can take this as 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. We can take this as 2 2 4 6, 8, 10, 12, 14, 16, 18, 20. This is good enough. So the first thing, the height we need up to 50 something, so we can take it as 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that's it. Let's label this 3.5. So if this is 2 and this is 4, then 3.5 is somewhere around here. This is 3.5. Then we need 6.5. So 4. Then we have 6, 6.5. This is somewhere around here, 6.5. And the height of this building is going to be 5. So it is going to be like this. This is 5, so it will be this. So this is 5. The next one is 7 to 8. That means 6.5 to 8.5. So 6.5. This is 8. 8.5 is somewhere around here. So this is 8.5. And the height of the building is 14. So 5, 10, 15. So 14 is here. So this is 14. This is an approximate sketch because here the boxes are very small, so it will give you an idea how the sketch is done. The next one is 9. 9 means 8.5 to 9.5. 0.5 minus 0.5 plus. So 8.5 to 9.5 is going to be, if this is 8.5, 9.5 is going to be around here. And the height of this building is going to be 49. So 20, 25, 30, 35, 40, 45, 50. So 49 is going to be here. So the height is going to be here. Okay, it will give you a rough idea. So this is going to be 49. The next one is 9.5 to 10.5. So 9.5, this is 10, 10.5 would be here. So the height would be up to 53 this time. So 53 is going to be 50, 51, 52, 53. This is going to be the building. The next one is 10.5 to 12.5. So this is 10.5. Now this is 12. 12.5 is going to be this. And the height is going to be 15. So this will be the height. This is the height for that building. Now this is 12.5 to 15.5. So if this is 12.5, this is 14, this is 16. So 15.5, somewhere around here, 15.5, and the height of this building is going to be 5. So this is going to be 5. Okay, the next one is going to be 15.5 to 20.5. So this is going to be 16, 18, 20. 20.5 is going to be here, and the height of this building is 2, so it would be here. So this is 20, this is 18. So this is going to be the histogram. Since we have a gap here, for that reason we have to take the continuity correction of 0.5 and 0.5. The next question is, give reason to justify the use of histogram. The reason is always if the data is continuous. If the data is continuous, we have to use a histogram. So B is going to be, since time is continuous, we need to use a histogram. In this histogram you will see that it is still, we have a gap here from 139 to 140, so there's a gap here. So it is going to be similar as the previous one, but this time one thing has to be noticed is it doesn't start from 0 right away, it starts from 90. So there is a gap in the data. If we start from, if we draw an axis here, me draw this axis. So if we draw this axis here, then it cannot start from 0 right away. It has to start from 90. So this is a problem here, because you cannot just start from 90. So this is called a broken line. We can give a broken line here. Let me change the color to see better. So since we're going to start from 90, so we can start from 90 right away if we give a broken line here like this. So this represents that there has been a break in the data, and from 0 we can right away start from 90. So we can just write this as 90, so that when we need 230 we can do 90, 100, 110, 120, 130, 140, 150, 60, 170, 180, 190, 200, 10, 20, 30. So in that way, so from 90 to 230 this can be done very easily. So the labeling of the x-axis is going to be time this time. The labeling is always the data, so this is the time in minute. The y-axis will always be frequency density, FD. So when we draw a histogram, the first thing that we need to know is the frequency density. Frequency density is frequency divided by class width. So since there is a data here again, so it will be 139.5 minus 89.5. We can just subtract it. 139.5 minus 89.5. So we can just do 139 minus 90 plus 1, the shortcut method. So this is 50. So 8 divided by 50. Then we have frequency is 10 divided by class width is 149.5 minus 139.5. Because of the continuity correction, there is a gap in the data here. So 149 minus 140 is 9 plus 110. Then we have 10 divided by 159 minus 150, which is going to be 9 plus 110 again. Then we have 169. This is again 4 divided by 10. Then we have 4 divided by 10. Then we have another 4 divided by, let me check this one, 229 minus 180 plus 1. This is 50. So let's calculate this. 8 by 50 is going to be 0.16. This is going to be 1, this is going to be 1, this is going to be 0.4, this is going to be 0.4, and 4 divided by 50 is going to be 0.08. So the height of the histogram is going to be very small. We better take something as 0.1, because the highest we need is 1. So we can consider this as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and we have 1. So 90 to 139 means 90.5. So just it doesn't have to be that accurate. So before 90, this is 90.5, and 139.5 is going to be 90, 100, 110, 120, 130, 140. So this is going to be pretty big. So 139.5 is going to be near to 140. It doesn't have to be that accurate. And the height is going to be 0.16. So this is 0.1 and this is 0.2, so 0.16 is going to be around here. Remember, the one that I'm drawing, because of this, it's not going to be that accurate, but it is going to give you an idea of what it's going to be like. So this is roughly 0.16, so 0.1, and we have another 6 here. The next one is 140 to 149, meaning 139.5 to 149.5. So this is 139.5, and this is 150, so 149.5 is somewhere around here, and the height of the building is 1. So we go up all the way to 1. So all the way to 1, all the way to 1. The next one is 149.5 to 159.5, so this is going to be 160. So 159.5 is here. This is also going to be 1. Now we have this up to 169 point, so it means 170, and this height is 0.4. So 0.4 is this. Then 179.5, which is 180, and this is also 4. Then we have this 229.5, close to this. This is 0.08, which is going to be less than 1. So this is the histogram. One thing you might do to add a finishing touch is when you draw a histogram, after that you can shade your histogram so that it stands out, just to give it an idea so that it doesn't blend with the graph paper, just to give it a shading. Don't spend too much time shading, just a rough idea. Remember, when you draw the histogram, we need the label axis. This is very, very important. Now let's do one sum where the data has no gap, so means we don't have to do any continuity correction. So 10 and 10, so that's it. This is the class boundary, and that's it. So when you draw the class boundary on the x-axis, all you have to do is 5, 10, 20, because there is no gap here. You don't have to put any 0.5. Let's start with the frequency density. So FD is going to be frequency divided by class width. So now here you don't have to do 10.5 minus 4.5 or anything. You just have to just subtract it. 10 minus 5 is 5. Frequency 16 by 20 minus 10 is 10. Very straight. 20 divided by 25 minus 20 is going to be 5. 18 divided by class width is 30 minus 25 is 5. Then this is going to be 20 divided by 40 minus 30 is 10. 14 divided by 60 minus 40 is 20, and 12 divided by 90 minus 60 is 30. So let's calculate. 8 divided by 5, 1.6. This is also 1.6. 16 divided by 10, this is 4. 18 by 5 is 18 divided by 5 is 3.6. 20 divided by 10 is 2. 14 divided by 20 is 14 divided by 20, 0.7. 12 divided by 30 is 0.4. Now let's draw the axis. The data here is length. So length, the labeling is very, very important. Unit in centimeter, and the y-axis is always frequency density. It starts from 5 and ends at 90. Let's try to see whether it works here or not. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. So we need one more. Let's see how it works out. So the height is 1.6 up to 3.6. If we use 0.5, it's going to be 0.51, 2, 3, 4. So the first one is from 5 to 10. So here we don't have to do the 0.5 continuity correction. This is extremely important. Since we have no gap here, the class boundary is the limit. So 5 is the class boundary, 10 is the class boundary. There is no need to do continuity correction because there is no gap here. So the height is going to be 1.6. So 5, so here to 10 here, so this is 1.6. The next one, 10 to 20, the height is 1.6 again, so 10 to 20, so 1.6. The next one is 20 to 25. 20 to 25, the height is 4. The height is going to be 4. 20 to 25. The next one is 25 to 30, and the height is going to be 3.6. So 25 to 30. Height is 3.6. Next one is 30 to 40. Height is 2. So 30 to 40. So the height is 2. Then 40 to 60, the height is 0.7. So 0.7 is going to be around here to 60. So this is 0.7. And then we have 60 to 90, which is 0.4. So 0.4 is here. So 60 all the way to here, maybe around here to 90. And then we can do some shading. That's it.